Yes, sir, we are live.
Good afternoon, madam. It's very nice of you to have joined this presentation today. You know, this is the first death anniversary commemorative workshop of CEG Gesto. He's a legend in the field of highway technology in India. So now, it was very kind of Mr. Vivek Das and Pramod to have organized this program. And I welcome you on this board, madam. Today, your presentation is here and it is being beamed all over the world. And there are 500 participants who have registered for this. Apart from that, there are few speakers are in line worldwide. So thank you very much for coming. Now you can start your presentation. Before the presentation, Dr. Vivek Das will give the brief introduction of your man. Thank you.
Thank you, sir. Thank you.
Vivek, continue, Vivek. Vivek, you have muted. You have muted.
First of all, I thank Ms. Preethi Raj to come here and to deliver a talk on GIS in transportation. So let me introduce Ms. Preethi Raj. Ms. Preethi Raj has done his BE from Bangalore Institute of Technology, Bangalore, and she has done his MS in Civil Engineering from Tennis Technological University, USA. She was an adjunct faculty in Nashville State Community College, and then she has shifted to as a quality and data analysis at Discover Education as at Nashville, USA. So then she worked as a faculty in MEJ College and CMRIT College, Bangalore. Presently, she is a GIS researcher and partner in Spatial Technologies, Bangalore. Her area of interest are geolocation mapping, traffic congestion evaluation using QGIS, route maps for carpooling, etc. She has published a paper in various journals and conference. On behalf of the department and college, I welcome you, madam. Over to you, madam. Thank you.
Thank you, Dr. Vivek Das. So I first of all thank the entire Department of Civil Engineering of the Anand Sagar. So today we are just going to have a discussion on application of GIS in transportation. So before starting, I would like to acknowledge all the departments and the websites from where I have collected my today's presentation. So the ESRI, which is the company which is known for the GIS products, ArcGIS, and other NPTEL, GIS Geography, Science Direct, thank you. So today my sequence of the presentation is going to be as such, like just a small introduction about my company. Then I'll just introduce on GIS, that is Geographic Information System. Then we'll discuss on GIS project life cycle. Then we will try to kind of see the applications of GIS in transportation engineering and the challenges. This is a very famous saying by Mr. Irvin Josephus. So the good cartographer is both a scientist and an artist. He must have a thorough knowledge of a subject and the model of the earth. He must have the ability to generalize intelligently and to make the right selection of the features to show. These are represented by means of lines or colors, and the effective use of lines or colors requires more than knowledge of the subject. It requires artistic judgment. In simple, this has to be the characteristics of a GIS researcher or a specialist. So cartographer is the person who makes map. So ecospatial research technology. So we started our company initially as an NGO to solve the civic issues. So that's where we kind of started using GIS because it can integrate various forms of data and can help in identifying the issues by location and then try to analyze, and also we can present the data visually. So that's how it kind of helps in representing the problem and the solution to it visually, which helps for a better understanding. So in the process, we kind of understood that the learning, necessity of the GIS knowledge. So that's how we started the training program. And we have been one of the pioneers in starting the online live GIS training sessions. So it's a live one-on-one training sessions we have done for few foreign students and all, as well as the natives. So during our process course of time, we have kind of worked with various NGOs, research organizations, and government departments. To name a few, it's like Arocha, BPAC, Government of Karnataka, BBMP, BJP, etc. And some of the projects which we have kind of have done, this is just few maps which we had kind of and we had created heritage map, then a guide map for Mysore Zoo and the Bannerghatta National Park, density mapping for various things, like for even for the school and the civic BPAC civic leaders. One interesting project which we had done was for the election campaigning. So ward wise the booth analysis. So here we integrated the analytics with GIS, for analytics to analyze the kind of all the the previous year's data based on the for the parties, and we visually represented through GIS. So that's why it was an interesting project. And then we have also done few studies for the traffic management and so on. All right, so now we'll begin with the introduction of GIS. So, in simple terms, GIS, the full form is Geographic Information Systems. The geographic can be also geospatial. Now, recently, that has been the term used commonly. So, here, geographic or geospatial means or relates to the place on the Earth's surface. Okay, so for time being, it's Earth's surface. In future, it can also be any planet surface. And then next is the information system. So where what are all the data which is collected about that particular location on the surface is kind of stored, manipulated, summarized, queried, edited, and then finally visualized. This works with the computer database systems. So in short, to put in, GIS is the system where you have the geographical or the spatial representation in the front end and the database in the back end, which is integrated together to work well. So thus we kind of define GIS is a computer-based information systems designed to accept large volumes of spatial data derived from variety of sources and to efficiently store, retrieve, analyze, model, and display these data according to the user-defined specifications. So if you just see this figure, simple illustration where we have the real time or the real world representation, which has n number of data based on, let it be, it can be on the environment, it can be about the surface, it can be about the buildings, or it can be on the land use, land cover, transportation, various things on the surface. But we can break it into simple blocks, that is the layers, and we can store the data respective, the respective data of each layer. So in that way we kind of maintain a very organized database system. And we can also kind of we have the softwares which can analyze and kind of um, finally give the output using all the data. So why is GIS unique in particular? Because it can handle spatial information system. And it can also kind of make the connection between the activities which is happening within that spatial proximity. So that's how it has become powerful, because we can visualize and also see the connection between the neighborhood. So in that way it becomes easy to identify the problem and then try to come up with a solution. And why is it useful? Because any event happens now, right now on Earth surface, it is concerned with some or related to some location, spatial location. So GIS can help us handle all this data, all the spatially referenced data. And one more plus point of GIS technology right now, it can be integrated with n number of fields. You name a field, you can apply GIS technology there. Like let it be military service, agriculture, transportation engineering, hydrology, geology, real estate, urban planning, journalism, sociology. Right now, you see all the maps pertaining to the coronavirus. It's all, the journalists, they use that, the technology to kind of quickly visualize, update the database and present it and that way. And it can also can be used in, that's what various branches. Just a schematic representation of where we can apply, GIS. So you can apply in like a site selection, demographic analysis for elections. Also these days GIS used a lot. Network analysis, that's what we are gonna, just go through it. Then logistics and routing, this is also one popular what do you say, the branch or the area field where it is extensively used. Facility management, etc. You can just go on with that, even in the medical research also. Now let's just look into a typical GIS project cycle. Okay, so in the GIS project basically comprises of these stages. That is, the first one is the defining the problem, then kind of get the relevant software and hardware to work with. The next one is gather data and clean data. That's a very important phase in this GIS project lifecycle. Then perform analysis. The final stage would be interpret and present the results. So problems, defining problems or scenario can be based on, various fields. Like just few to mention here can be hazardous spill, the oil fills, leakages, then identifying the assets that will be vulnerable to flooding. The insurance agencies or the companies use this a lot for this. Monitoring logistics and then modeling storm surge, forest fires, creating multiple spectral imageries, then performing to kind of know the land cover and land use data. We do the supervised and unsupervised imagery classification, then monitoring and managing intermodal transportation, rescue operation, and so on. The next step in the life cycle is get the right hardware and software, because right now that has become very important. Because now the data what we have is not just, few points, it's like millions of data. So which we should have the capacity to compute it and kind of present it, kind of interpret it, present it. So that's where the hardware is actually important part in GIS lifecycle. So we can just start the input with the simpler one, the scanners, where we can use it for digitizing the hard copies of something like topo sheets. And then recently, not recently, with the advent of satellites, it has become much more easier for us to acquire the data. Then GPS and drones are kind of playing a very important role. Then comes the CPU, hard drive, and LAN. So these components of the hardware is very important if you have to process a large data. Then the final thing is the output. So printers and plotters were very common, but with the kind of, now the GIS technology has improved such that you can publish it, you can web publish it. In that way, that is getting more popular. Softwares, ESRI is one of, I would say, the best or the most popular product, and they are really kind of big into this market. They have various products, right from the desktop version of ArcGIS to enterprise, and they have the ArcGIS kind of integrated with the BIM module. They're gonna in future, I mean, it's almost gonna come up in just few years. They're gonna integrate Arc products, GIS products with the artificial intelligence. So they are big into this industry. We have Bentley Maps, MicroStations, Global Mapper, ILWIS and all, map windows. And we also, since GIS has started being used extensively across various departments, open source products also have become more popular. One of them is QGIS, which is almost on par of ArcGIS. It almost represents the same kind of framework, similar framework, and they have actually improved quite a bit. So it's at least 80% of our desktop version QGIS can perform. But one advantage of QGIS, the open source products, is you can kind of integrate with various other products and kind of create your own customized automated version, no, for the automation. In that way, that is kind of useful. Fine. The next stage, that is the third stage in the life cycle, is gather and clean data. This is a very important phase because previously the challenge was to acquire the data. Recently, that's what, as I said, as satellites, then the advent of the GPS system and the drones, lidar, and everything, we are able to acquire the data. So remote sensing, photogrammetry, aerial photography, all these kind of helps in getting acquiring the data. So now it has actually become much better and accessible to get the data, and we also can do a specific data collection based on your project. So that is also possible. But the important step in this is we have to clean the data, because we have to validate, we have to verify the data, that what the data sets, whatever we have kind of gathered. Because if the errors are not verified or not validated, or it's not corrected, the errors can propagate. So then the next steps, whatever you kind of do the analysis, and your results might not be accurate. The errors there can propagate, and it can cause it won't be that useful. So the main thing is, what can be the issues, the data, it can be from of different scales. So that data says what you have collected can be of different data scales, and it can be from different projections, because each country follows their projections, and the whole world, they have one single projection also. Then there can be some spatial inaccuracies, like if it is like those vector data, you can have some overlaps or gaps, which has to be kind of checked for its inaccuracies, and should be validated. And there could be some errors in the attributes, that is the information, what to store the database, because there can be some values, missing values, or the spellings, it could be misspelled. Those few kind of things. So we have to make sure we kind of reproject all the source layers to a single projection. And then the next one is to check, we need to check for all the spatial data geometry issues, make sure there's no overlaps or gaps or any missing data, and even the attribute information we need to kind of check. All this is to make sure that we don't have much errors. So when it comes to spatial data, the main components of spatial data, it's like there are like 4 components, like location, spatial relationship, attributes, time. So I've just here just a small clip from the Google Maps. I just where this, it indicates, the pointer indicates the Dayanand Sagar University. So if as a now if we consider Dayanand Sagar University as the spatial data here, the first component, location. So we need to know the latitude and longitude of this location. Then the spatial relation, that is the connection between the other spatial objects in and around the university. It's where is the what is the Kumaraswamy layout ground is kind of located, how far is it from the main road, and what is to the north of the uh, university. So these kind of connections, we kind of that's how you can. Then comes the attributes, that is the information which you store it at the backend or in the database. So it can be anything, you all possible data you can store about the university, when, in which year it was started, how many departments were there. You can have the timeline of that, the university, how many students join every year, and what is the placements. So all those records we can maintain. So everything, it defines the character of our location or our data. Then time. So this is an important aspect if you want to kind of see the variation. If you want to see the dynamics of that. Based on the time, what is the changes happening? In and around the university and within the university. So in that way, we can kind of. So any data we kind of acquire, these are the main 4 components. Next, the characteristics, generally just to kind of, just be familiar with the characteristics of spatial data. So it's usually multidimensional. voluminous. That's one thing. So that's why we need a special technology to handle it. Then requires the projection to the flat surface. As you all know, it's like sphere, but in reality, when all the mathematical or statistical, whatever the procedures, algorithms we apply, we try to use the flat surface projected flat surface for the calculations. Then the analysis methods, though we all use the mathematical and the subject oriented algorithms and the models, still the method has to be, it's a little unique. It also requires data integration. Then sometimes these data updates can be expensive and time consuming. And also the map displays requires a fast data retrieval. So this is where the technology plays an important role here. Yes, next. So basically the formats, which works with the GIS softwares, it's like, so data models, what we call it as the data models. So they are nothing but the geographic data, which is represented in the digital format, because the GIS is a software which we work with in the system. It's a thing. So in simple terms, what we can say is the data model is a set of guidelines that represents the logical organization of the data in the database, consisting of logical units of data and the relationships between them. So that is a data model. And each data model fits a certain type of data and applications, because we apply GIS in various fields. So based on the problem or the issues, we can decide which model to kind of use it, right? So um, like data model is like categorized or divided into two categories. One is the raster format data model, and the other one is the vector data model. Just this a very simple representation here. We'll just, in the next slide, we'll just see the details. Okay. Raster data model. Just in a very quick understanding way, if I have to tell, raster data model is something like an image or a picture. All right. So that means if you see any image or a picture, what we capture using a phone, the cameras and the phone, if you just try to observe it, it is all made up of pixels, that is small regular grids or cells, small squares. So that's the thing. So raster model divides the entire study area into a regular grid of cells in specific sequence. And here, if you just see, the entire image is kind of filled. Every location of the study area and the kind of, in the raster model has some value, and it corresponds to one particular square or a pixel or a grid kind of thing. So the cell of this size of the cell defines the level of the spatial detailing. This, I think, now everyone understands, because as the resolution is higher, the images are crisper and clearer, right? The same concept here also. Then when you consider one cell, that is one unit in of a raster image, so whatever variations are there within this are all lost, and finally an averaged value is kind of maintained for each cell. That's how the raster image data model works. Then one set of cell here kind of is associated with one value. So one cell can kind of incorporate any one value. It can be a numeric value or it can be a character, but it can kind of accommodate just one value. Right? Then the raster model kind of tells what occurs at each place in that area. So if you just consider one area, each and every place it has some data. What happens. That's the thing. So there are just few images here. DEM is, that is digital elevation model, is one of the most common raster data which we use it extensively. So where this here, each and every pixel or the cell or the grid has the data of about the elevation of the surface. So this is a kind of a black and white scale of representation, where the area where the black color indicates the lower elevation and the white region indicates the higher elevation region. The same thing we can also represent it, with the color coded or thematic, where we can give the variation. Here we have few maps just showing the temperature variations across the world. So these are some examples of the images, or raster images. Now next, moving on to vector data model. In simple terms, vector data model is defined as a point, line, or a polygon. So just to remember it, that's a very quick way of doing point, line, and polygon. So the primitive unit in a vector data model is a point. Okay, and then connecting, like, points together, connected, they form a straight line. Then the sets of lines form a polygon, or the area which defines under the set of lines is like polygon. But what is unique about this vector data is like where you have this, every piece of boundary line is common boundary between two areas. That is one thing. And when you consider a line, it kind of goes with the concept of the node uh, and edges. What we use this concept for even network analysis. Node and segment, or the vertex and edges. So that's one thing. And one more important, what do you say, the property of a vector data model is it can store more information. Not just one attribute, it can kind of store multiple attributes. It has a kind of inbuilt database, where if you have a point, you can kind of store the information, that is the latitude and longitude about that point. You can store uh, what is in that location. It's, if it is a building, or and in which country it is, in which place it is, you can store, or anything related to that. So n number of attributes you can store. So that's one speciality of the vector data model. So you have an inbuilt database kind of thing. So attribute tables, what we say. So here we have a few simple representations of the vector images, like locations. Here it's a map of the schools in Bangalore. So you can just see it is all located in points. And then we have some street maps, so lines. Then administrative boundaries like districts, states, countries, all these things are represented by the polygon model. Okay, coming to the difference between vector and raster data model. Vector is discrete, whereas raster models are continuous. Every cell in the image has some value. But in vector, that's not the case. It's discrete. If there's a point, that point has a lot of information, but not the other areas. So similarly, usually vector is represented by the coordinate system, the latitude and longitude, whereas raster image, it is defined by using the matrix of square areas. We kind of any location, if you have to kind of represent in raster, it will be a matrix of square areas. And then vectors, we can store and retrieve multiple attributes. You can store, you can kind of delete that, you can retrieve, you can do a query to only select few attributes. All these kind of things. It's possible with the vector data and vector models. But whereas in raster models, you can store or retrieve either just one numeric or a character attribute. Like, if there is an image, a raster image, it will give you data pertaining to only one attribute. Maybe it can be just only about elevation of that particular area, or it can be some soil moisture content pertaining to that area, or some precipitation data or temperature asset. Now next, coming to the formats, because it's a software, we use the formats, to work with. So shapefiles, KML, so that's used in Google Earth quite a bit. Drawing maps, that is the AutoCAD drawings, also can be incorporated as vector files. Then geodatabase. Then coming to the raster, as you all know, JPEG is the common image format. Then we can also use the image and the TIFF formats. Next, going to the next stage of the life cycle of a GIS project is the analysis. So as a software, there are like these inbuilt analysis which can be performed using GIS. So we can do a database query, because we can store and retrieve a lot of data for the vector file, so that we can kind of do an analysis within. Then the geospatial measurements we can do, because it is map making where the geometry is kind of concerned, we can do this. Overlay operations. So here overlay operations is one of the unique thing towards the GIS, because we divide the entire area into layers. We store certain data pertaining to in certain layers. So if you want to kind of analyze it together, so that's when we want to consider all the parameters. We want to consider two or more parameters. That's when we can use the overlay operations. Then the network analysis, surface analysis, like pertaining to the terrain, and as such, like slopes analyzing, trying to calculate the slopes of the area and as such. And then the visualization, this is also one of those unique part of GIS, because after analyzing everything we can visualize spatially, spatially it's like geographically referenced visualization. Then geostatistics. So whatever the results we analyze, the final stage of our life cycle is going to be interpreted, present the results. So the results can be presented in various types of maps, like topographical map, thematic or choropleth maps, navigational charts, cadastral maps, and plans. So just few images, representing each type of maps. The topography, where we can kind of represent all the physical and natural features. Thematic is whatever data we have and stored in the database. Based on that we can do an analysis and present it. And navigational, like the best example for thematic maps is like right now, I mean, everyone are very very familiar with the coronavirus, and they keep updating the maps. So that's a thematic map. Navigational map, this is used in kind of the monitoring of logistics and any kind of transportation. In that field it is monitoring, that it's a very effective one. Then the cadastral map, so when the government agencies want to kind of administer the our the entire the districts or the state, so these kind of maps do help in those. Fine. So we just had a small introduction about GIS and its life cycle. Now we'll just try to just go through some of the applications in transportation. All right. So now, if you see, transportation engineering is one of the few fields where GIS is used extensively. It's like to the best they have used it. Let it be the government departments, let it be the businesses, let it be the other modes of any mode of transportation, they have used this extensively. So that's where it's very popular in this, and knowledge of GIS is really very useful for you to, if you want to have a better career, in transportation engineering. So that's because the main reason is because, see, even transportation is dependent on visualization and analytical methods. Whatever we follow, it's all based on the time space. So transport means moving from one place to another, so that's where the location comes in. So that means GIS obviously comes in, kind of thing. So that's where that's why it's used so extensively. So now when we just try to see the approach, GIS, try to apply in transportation, we can apply it in like two different fields, kind of thing. So one is to kind of uh, develop and enhance in order to meet the needs of the transportation applications, the fields where we apply all this. Let it be aviation, let it be fleet management, the vessel tracking, highway and railways. So all these fields to kind of, it helps in um, enhancing, there's a need for still to kind of enhance and make better data integration and give a better support for the GIS technology, so that you can apply it effectively and efficiently. The other kind of aspect or the branch where we can apply GIS is to improve the transportation studies, facilitate and improve. Because again, if there is an issue maybe on a highway in Tuka, because that's again pertaining to a location. So so that's where we can kind of try to analyze and study using GIS. So that's how these two fields is where it's kind of applied. So coming to the transportation, GIS application in transportation, I would just put it in in a short form as GIST. So here studies, we can divide this into three categories. The studies, so that is, one is for the data representation. The second one will be in analyzing and modeling. The third one is the application. So these are the three kind of branches where the GIST can be studied. Data representation is in very simple terms. Whatever assets you have, anything concerned with the transportation engineering department, you can represent it, locate it, map it, and kind of use publish it, web publish it, so that people are aware of its locations. So it can be road assets, you can locate them. Then the deadliest roads also we can kind of locate and map it, so that people are, you can if you publish it, people can, I mean, every department can use, and even the civilians can be aware of it. Street repairs, so you can kind of locate if there is an issue, if there is a pothole or some those kind of issues, or if there is somewhere they have dug in and not done the work, not done a good job. So all these kind of all these reporting and inventory can be maintained. Sidewalk inventory, so all these things we are mapping the facilities, mapping the existing facilities. Then the bridge inventory, you can also use it to present the inventory of bridges, map it. Road assessments, so like this. So we can just see there's a small representation of system, a set of roads or a road network. So here we have represented it, where is the highways, where's the expressways, and where are the intersections, major intersections, and just the neighborhood intersections. And if the road system, that is the network of roads also, we have classified whether it's a local road, or it's a street, or is it a major road, regional road. So because the speed limits also varies according as per the functional or function of the roads. So in this way we can, this is a good tool to represent, and publish it, where it can be made available for everyone, because they can use this. Now, coming to the analysis and modeling. So, analysis and modeling here, all the concepts are all based on the mathematics and network analysis or graph theory, which has been used for decades. But with the advent of GIS, is what is the difference is it has kind of made it more efficient and faster. That's the main advantage of that. So now let us just check into the shortest path analysis. This is one of the most popular algorithm, like I mean, now everyone, I would say almost 90% in the world use this algorithm in their day-to-day life. Simple Google Maps. I think we don't start our day, we don't get out of the house without seeing the Google Maps. So that's the thing. So this shortest path analysis, this concept is used in Google Maps. It's a very old algorithm. It's been like more than like 6 to 7 decades. So in what is, like shortest path analysis is just generating the shortest, fastest, or the least costly route between any number of origins and any number of destinations. With if you have any intermediate points, you can add on to that. So the whole concept is based on the concept of accessibility. What is the accessibility of that pertinent pathway? So, so accessibility, we can define it as the measure of the capacity of a location to be reached by, or to reach different locations. So that's how we can just measure. That's how we can define it. So, and it depends on two factors. Uh, that is the capacity and the structure of the transport infrastructure, the key elements. That's the thing. Or the two concepts could be like the transport infrastructure and the distance. Fine. So as I said, this application of SPA, one of the most popular algorithm is Dijkstra Algorithm, which has been there for a while. I think around 1960s it has been used, like almost like 7 decades, 6 decades we have been using. And this algorithm is also used in the Google Maps. So just a quick, we'll just try to go through in a very simple way what is this Dijkstra algorithm. See, now we have points A, B, C, D, E, F. All these are the locations, and this is connected by. So these are the nodes, what we say, and it's connected. The connection is called as the edges. So which is pertain to some weightage. So in the simplest weightage, what we can give is the distance or the travel time. Okay. So now if we have to for kind of calculate or estimate the fastest route, So we have these possible routes, like if we have to travel from A to F, so we can just travel from A to B, B to D, and D to F. Then we can travel through A to B, B to C, C to E, E to D, and then F. Then one more is A to C, C to E, D, and F. So when we kind of try to get these permutations, we have to also consider the weightage that is of the edge. So in that way, when we try to add, this is a simple way where we just arithmetically add it, and whichever show the value, whichever is the lowest, we consider that to be the fastest or the shortest path. Okay. uh, so but this is right now, it's also being used by Google Maps. That's why, I just wanted us to kind of be familiar with that. um, this is just a simple illustration. um, if you have to try to get the route between Dayanand Sagar College and Phoenix Market City, so just it's, see, distance is going to be constant, 26 kilometers. So this, when I kind of tried to check it yesterday at certain time, it showed as 49 minutes. You have an option. This, I think it is there in the mobile phones, but not on the website. You can, whenever you log into maps.google.com in a system, this option is not there. But in your Android phones, I think this option is there, where you can try to set the depart or arrive time. You want to check for tomorrow, or after, like, I try to check for like Thursday and Sunday, for some certain, for a given time. It kind of, see, obviously the distance is not going to change, but it could estimate the time. It can vary between 45 minutes to 1 hour 20 minutes. So now this is the variation uh, given to the our old algorithm. For the old algorithm, we have kind of added this one more constraint, or the one more dimension, that is estimating based on the cost or the uh, time. That's one angle. So next, coming to one more popular analysis or modeling in network analysis or the transportation, is traveling salesman. um, Now this is also again used extensively. Like now, if you see the school bus routing, let it be our transits, let it be the company, college buses. So all these places, they kind of use this. This is a simpler version of that, but it's extensively used. This concept is used. So that's why, in very simple terms, if a salesman has to kind of has some 10 different locations where he has to visit and then be back to his original destination, what's the best path he can take, where he can cover all the places and not spend much time or cost, just take the shortest route, also the best route here. So that's again, this is also based on one of the, what do you say, very old algorithm. It's a mathematical algorithm where they try to use permutations here. So when we have just 6 locations, just if you have to do the permutation, it's like around 6 factorial, if I'm not wrong, around 720 permutations, I think. For 6 points, we have to do so many permutations. Imagine if we have, like, hundreds of points, thousands of points. So the computation requirements goes higher and higher. So that's where these old algorithms need a powerful tool like GIS to kind of make use of this effectively and efficiently, and also monitor them too. Now these two, the concepts have been very old, as I said, but still very popular. But in today's time, what is that it's making a difference? Well, that's the thing. See, the algorithms assume that the whatever weights we provide are supplied are kind of accurate. But in today's time, the issue is just a simple thing. If you have to travel from Dayanand Sagar to Banshankari bus stop, maybe it varies. The distance is same, but the traffic conditions varies. Time of the day, it varies day of a week, and it varies depending on the weather conditions, traffic conditions. So it's more dynamic. It's, it varies a lot. So that's the challenge what we are facing, and that is, accurately estimating the weights is the major challenge now. Estimating and then computing it and then kind of reverting back. It has to kind of I think. So that's the challenge we are facing these days. So that's where GIS comes to our rescue, because with the advancements of computer power and algorithms, kind of have helped in accurately predicting these weights. So as the number of points grow to millions, big data frameworks like Hadoop are used to perform these computations in a timely manner. Um, and also the AI, the artificial intelligence and data science is also used to predict these weights with a high degree of precision. That's what I said, you right, when I showed you the Google Maps thing, it was able to predict the time. So how did it get that value? There should be what do you say, evident, a validated procedure to get that, to predict it. So how? That's based on the data science. They now recently they have been able to acquire data, so that which helps them in predicting. So in just as to summarize, I would just tell, like, GIS serves as a platform to combine traditional algorithms with spatial data and data science to create life-changing user experience, which helps efficiently monitor and management. So that's why GIS is getting more and more powerful, you know. Okay, then we have few more analysis modelings, like it's like based on the intersection analysis, trip generation production. This is also a very popular estimation, or it's like most used, I would say, or kind of in the network or transportation engineering. Bike sharing. So right now we see even in Bangalore, this has become like from metro, especially in metro stations, you have the bike sharing options. So all these things, the routes are set, it's monitored using a GIS platform, then managed. So all these things are possible because efficiently, it's been, we are able to do it efficiently and effectively. It's because of the GIS platform. Bus routes, as I said, because for the bus routes, we also have to consider the cost and also the demographic impact. So we have to consider, we need to integrate various data sets, parking demands, then the A/B testing, OD, the origin destination cost metrics, intermodal transportation. So in the field of like cargos, logistics, and all this is very important and challenging. Fine, now coming to the applications. So we saw the data representation part, then we saw GIS, how it can be used in analyzing and modeling. And all these things we do to apply, we kind of apply it for have a better system, very, what do you say, a user-friendly environment kind of thing. So it's applied in fields like intelligent transport systems, infrastructure planning, design and management, transportation safety analysis, travel demand analysis, traffic monitoring and control, public transit planning and operations, environmental impact assessment, hazard mitigations. So on. We can just apply it in various fields. One more interesting and right now very, what do you say, it's a very strong system, like, is the intelligent transport system, because with the advent of all the satellite technology, remote sensing, and kind of, with all the sensors what we have, GPS technology, integrating all these, we can kind of create an intelligent transport system which really helps in managing the traffic. So a traffic management center is like mainly a technical system. So the intelligent transport system is like a vital unit there. So here, what are the things? So it's like where we need to collect the data, analyze it for the further operation and control management, of the traffic in real time. That's the main thing here, real time. So efficiency of these operations really depends on the automation of data collection. So just automation makes it faster and kind of effective with the precise location information. So just the process, if you have to just summarize the process of an intelligent transport system. So the first part will be the data collection, then the data transmission, data analysis, then the travel information. So it's like if you have to kind of find out there has been some issue or what do you say, accident or something. So we need to be precise in collecting the data, the location of that accident, and all other details connected to that, whether it's like between the accident is a major or a minor, what is the kind of damage, and how much time it will kind of take to clear. So all these things can be done using the sensors. Now what we have, automatic vehicle identifier, GPS based automatic vehicle locators, sensors, cameras. So all these hardware or the sensors are do a have come into a rescue, to do a better job of data collection. Then again comes the data transmission. See, one is one acquiring the data, and the next one is rapidly communicating it. It is real time dynamic. So we need to kind of communicate it rapidly. So for that we again use the thing like internet, SMS, or the onboard unit, so vehicles. Then comes the data analysis, where we have kind of analysis is very important. Data analysis is very important because we have to make sure it is accurate or at least validated. So we have specialized softwares, and then finally kind of giving the information to the passing on the information to the travelers. So we have again various methods. We have the advisory radios, internet, SMS, so all these things, right? So as I said, GIS can be, the whole technology, GIS integrated or the GIS integrated platforms can be applied in various fields like aviation, fleet management, logistics, highway, streets, mass transit, and railroads. So these are just few representations, the working module for the across the various applications. And one next stage, what an interesting thing is now, GIS also aids in planning the terrestrial phase of Mars Science Laboratory. There's this map, this kind of represents the terrain of Mars, and they try to identify the location where they've kind of tried to route or land the this thing, the rovers. So that's it. So that's why I said it's not now, it's geographic doesn't just hold on only to Earth. It can be now next planet. So that's what is interesting here. So, and it has been successful, they've been able to map it and kind of use it. Fine. Now coming to the challenges, what we had like in past and present, as I said, is the data management system. Because as we start collecting data, it's not going to be just few points; it's going to get into become millions. And then the data interoperability, that is also very important. We're sharing the data between various agencies, and we have to maintain the database and all those kind of things. Then real time GIS of transportation. So again, we have challenges in all this georeference data storage, then retrieval when required, processing it, analyzing it, then large sets. So that's where now Hadoop system and cloud computing, all these things are kind of helping us, even the distributed computing. So with help of the advancements in technology, we are seeing what do you say, a much user good what do you say easier user experience, in monitoring and managing the transportation system engineering. So just before I end, just having a insight on futuristic transportation technologies, what can be kind of thing. So one is autonomous cars. So that I think it's already in process and people are working on it, and they're creating a lot of maps to route the autonomous cars. Then comes the convertible cab cum storage. This is also going to be an interesting technology. Hyperloops. So this is kind of a loops where to avoid the friction and other resistance, so that the speed of the routes, can be the pods can be increased. Then the flying taxis. So some of the resources, and by this we just come to an end. Thank you.
Thank you, madam, for your nice presentation. So, madam has covered various aspects of GIS in depth, and she has specially explained the application of GIS in transportation engineering. So, we'll take some quick two questions. So, what
Yes,
I'll do is I'll just read out those things. You just answer that.
sure, sir.
So, first question they had asked regarding how the data is converted into system. That is, maybe I think they are asking regarding digitization.
Digitization, that's why it depends upon the data, sir. Now, if it is the data through remote sensing, we have the image processing, all this process already set. If we are kind of trying to use a vector data model, so digitization where there's a big team which does it manually, and we also have the database. Like, if you see, most of these GIS softwares are now integrated with the database. Like, they have their own database, and if you see, like, QGIS, an open source system, it can be integrated with Postgres database, the MySQL, PostGIS, and all these databases. So that's where we can, because when you have what do you say, huge number of data, just we can't directly use the GIS software to kind of use. So instead we try to what do you say, import all the data into a database, and then from there we try to use it or digitize it, use it for the digitization.
Okay. So next question is, can we use GIS for land use planning and mapping?
Yes, yes, very much, sir. It's already been used, and a lot of softwares also are helping us. Even recently, Google Earth also has come up with all this, to kind of come up with the land use, land cover thing, and also it's very much in use. That's what I would say. They are using it extensively.
Okay. Then with respect to bus route scheduling, can we use bus route
Yes,
scheduling? Yes.
yeah. That's what we have already. All the algorithms placed. We have it, and using GIS, it has made our work easier because we can get the routes. Previously, it used to be static maps, but now it is kind of what do you say, a digital map where we can use it to even to monitor and manage them also. Because I think in Bangalore, one of the popular ones which uses this technology is the North Star.
Okay.
I think it's by the Honeywell. I'm not sure, but they are using it very much.
Okay. Okay. Thank you, madam. Thank you for your presentation, and thank you for spending your time to share your knowledge with us. So thank you from our side. Thank you, madam.
Thank you, sir. It was my pleasure.
Thank you. Thank you. Pramod sir, we can end the session.